Okay, so we have gotten this hydraulic cylinder with a smooth round interior and a set of holes in it. These holes are rectangular holes with metal walls in between. And clearly, this is not going to be a hydraulic cylinder that will work because this would leak badly. It's a communication between the interior of the cylinder and the exterior of the cylinder. And at this point, we're going to mix together some components that are normally not seen mixed together with each other. And it's just a brand new way of doing something, and you have to see that. What we really want to do is take the activity of the interior of the cylinder and get that activity to be on the outside of the cylinder, because the measuring system is on the outside of the cylinder and the piston head is on the inside of the cylinder. And that has usually been why it's hard to use any sort of simple approach to measure the extent of retraction and extension of a cylinder, because you have a fairly strong, solid, uninterrupted steel wall. And we're making a point that these are some things that others have not thought of. There are many different types of ceramic materials. One of the types of ceramic materials that's available, and I've drawn it and colored it in with this coloration because that sort of looks like a ceramic to me. It's got multiple colors and it's transparent, and all that means is that this is ceramic. And I've picked a particular ceramic. The ceramic that I've picked is a ceramic that is transparent to microwaves. Not only is it transparent to microwaves, but it's heat resistant, hard, and strong, and can be machined, and has mechanical properties in terms of tensile strength close to aluminum. And the exact ceramic that I've picked, it's very interesting that this is hard to talk about because it is involved in some of the stealth related military stuff. There is a material called pyroceram. Pyroceram was discovered a long time ago and actually got pulled out of military use, brought into civilian use as Pyrex. But pyroceram is a glass ceramic material that's fairly resistant to fracture and breakage, and can be shaped, and can be heated and formed, and happens to be transparent to microwaves. And it's like, okay, it's transparent to microwaves. What do we care about that? And the point that I will make is, before we work through the microwave issue, understand that we can take these shapes, and we can have these shapes be present inside of this cylinder. And this is just industrial processes of bringing a ceramic material into an opening in aluminum. I think this can be done with 3D printing techniques. I'm not even sure we need 3D printing techniques, but remember that if you had a cylinder in here with a boron nitride coating, and you put the ceramic in here, and then put a boron nitride plate over here, boron nitride is not going to be melted or injured by the temperature of this pyroceram, and boron nitride does not stick to ceramics. So you can use a boron nitride coated placeholder or shape that will allow you to place your ceramic material only where you want it to be. And this structure on the inside of this hydraulic cylinder will be smooth and round, and the piston head itself will move back and forth through this cylinder without leaking, because you can force the pyroceram ceramic to be smooth and round by using boron nitride.